3.8, business applications. First, let's review on, give you a few new functions as well. Let's start with the cost function. Okay. 3.8, business applications. Let's start with the cost function. If you remember, the cost function, the input for the cost function was items, and the output for the cost function was money. The idea was the more items you made, the higher your cost would go. Now, when we first introduced the cost function, it was linear. Okay, represented by mx plus b. And when we looked at the cost function, okay, it was going up. So the more and more items that you made, more and more items that you input, the higher your cost would go. Now, this point right here, the y-intercept, this ended up being the startup cost. Okay, that y-intercept ended up being the startup cost. And it happened to be the constant b that was being used. Okay, and again, as the more items that you add into the function, the higher the costs go. Now, we're going to introduce another cost function that is a quadratic. Okay. Now, when we graph this cost function, here, we'll start inputting items, and the costs, you'll notice, are going up. In fact, they keep going up until you get to about that spot, but the costs are going up the more items that you input. And again, we have a point here that will represent the startup cost. Now, in this case, that constant, which is the startup cost, is represented by the letter C, as opposed to the letter B here. Now, with using a quadratic equation, we get a nice feature about the cost. The cost definitely goes up, but there is a magic spot when the costs start coming down for us, when we start using a quadratic, which is real nice. So we're going to have some nice features. Just the fact that we've upgraded our cost function. Okay, next. The average cost function. Okay, the average cost function is represented with C with a little bar on top. That's how you know that we're dealing with the average cost function. And it's found by taking the cost function and dividing it by how many items that were made. So if it's now costing you $600 but you made 6 items, you know that the average cost is about $100 per item. So this is why we take the cost and divide it by items to get the average cost. Now, a graph of the average cost will look something like this. Okay, and you'll see that the more items that you make, the average of the cost goes down. Okay, which is good. Basically, it says the more items that you produce, the less it'll cost to make those items as you go. And that's a good feature. So there's a couple ways of getting the price down, or the cost down, is that your cost be based on a quadratic, and at some magic point, the cost will start declining for you. Or we can look at the average cost of making so many items, and again, the more items that you make, the average cost itself will go down. Okay, next. the marginal cost function. The marginal cost function is a derivative of the cost function. Okay, it's a derivative of the cost function. The cost, the instant, we're saying at this one item, instantaneous, what is it costing us to make that one item? Average cost looks at from, we made 100 items, so how much is it costing us at average from there to there? Instantaneous says at one particular item, what is it costing us there? Let's get the graph of this. The graph of the cost function will be a function that goes down. Okay. Again, you have, this is the original function here, but the cost function will look this way. So the idea is that the marginal cost, the instant cost at any point, is getting smaller and smaller and smaller. Just like the average cost is getting smaller and smaller the more items that you make. Now what's a little different here is that this also suggests that if you keep making items, there is a point at which what it costs the instant to make an item will eventually be zero. At this point, to make an item, it'll cost you zero. And that is nice. We're very interested in when that happens. Okay. At that instant. So what is the x? So we'll label this. This will be the zero cost to make next item. Okay? If we know that the cost all of a sudden becomes zero, we know to make the next item, it's not going to cost us anything. And that's a good place to be. Okay, now, this is marginal cost, which gives us the instantaneous cost to make an item. There's also marginal profit. Which will be the instantaneous profit that is made from one particular item. To make the 20th item or 70th item, but at that instant we want to know how much profit are we making since we have sold that single item. Now, profit is made out of revenue minus cost function. Therefore, marginal profit, instantaneous profit, will be made out of instantaneous revenue, or the derivative of revenue, minus derivative cost function. Or should I say, the marginal revenue minus the marginal cost. Okay. Now, profit function can be positive or negative. There are some times that your cost is greater than the revenue, and so your profit will be negative. There will be times that your revenue is bigger than the cost, which is great, so your profit will be positive. We'll also look for when is your marginal profit going to be zero. Because zero lies just between negative, which is losing profit, and positive, which is gaining profit. So we want to find out what x causes the profit to become, the marginal profit to become zero, which is right in between losing it and right in between gaining it. So we want to know what number of items that we need to get to go from the loss of profit to the gain of profit. Okay. Page 276, problem number 2. We're given a cost function, c equals 20,000 plus 7x minus 0.00005x squared. Now I just want to describe this cost function. The 20,000 is the startup cost. The 7x is how much it costs per item to make. To make one item, it'll cost you $7. 2 items, 14 bucks. 3 items, 21 bucks. And so all that's being added to the startup cost. But there's some pennies here that are being taken away from your cost that's helping you. This doesn't kick in for a long time because it's so small. So for a while, your costs are going to continue to increase because of the 20,000 and the 7x. But eventually, if you make enough items, this x squared will eventually cause the cost to stop going up and finally climb down. Okay, well otherwise this cost function really is increasing for a good little while. Okay, we want to find the marginal cost at the instant we have made 100 items. The marginal cost the instant we've made 100 items. So let's find the marginal. So the derivative. Derivative of constant is 0. Derivative of 7x is going to be 7. And the derivative of this will be 2 times 0.00005 x squared. And the final marginal function comes out to be 7 minus 0.0001 x squared. Okay, so this will represent the marginal cost. Now, what is the marginal cost at the instant we have made the 100th item? How much is the 100th item costing us? Well, we'll put in 100 and we have 0.0001 with 100 squared. Well, 100 squared, if 100 has 2 zeros, squaring it gives us 4 zeros. So, 4 zeros. Okay, and finally we're 4 decimals back here times a total of 4 zeros here. This will give us 1. So 7 minus 1. And we end up with 6. So this 6 is a slope, which is input. The output is cost divided by items. So this is $6 per item. So when you make $100 items, that is costing you $6 per item. So I know that the next item will cost $6 more to manufacture because I know how much it costs right now at the instant I've made 100. So to make 101, I know it's going to cost me $6 more bucks. Okay, let's do problem number 6 on page 276. We're given the cost function, a revenue function, and we're being asked to find the marginal cost, the marginal revenue, and also the marginal profit. Well, the marginal cost would be the derivative. So this will go from 5x squared to 10x. The marginal revenue would be 3x squared plus 7, and the derivative of the constant will be 0. The marginal profit is made from marginal revenue minus the marginal cost. So that'll be marginal revenue, which is 3x squared plus 7, minus the marginal cost, which is 10x. And we can simplify, put that in order. So it'll be 3x squared minus 10x plus 7. Finally, we're being asked, when is the marginal profit 0? Again, 0 is the difference between losing profit and gaining profit. Okay? And we want to find out where that special x is, or the number of items that causes you to, as opposed to lose profit, to gain profit. At what instant is that happening? So, they asked us to set the marginal profit to 0. So, and from here we're going to solve for x. Okay, we're going to use the quadratic formula to solve for x. So x equals opposite of 10 plus or minus the square root of negative 10 squared minus 4 times a times c all over 2 times 3. Okay, and from there we have 10 plus or minus the square root. The negative 10 squared will be 100. 3 times 7 is 21, and 4 times 21 is 84. Okay, all over 6. Okay, from there, 100 take away 84 will be 16. So we'll have 10 plus or minus the square root of 16 all over 6. And the square root of 16 is 4, so we'll have two answers. X equals 10 plus 4 divided by 6, and x equals 10 minus 4 divided by 6. Okay, 10 plus 4 is 14 over 6, which reduces to about 7 over 3. And then over here we have 10 minus 4, which is 6, over 6, which is 1. Okay, here are two areas. When x is 7/3 or when x is 1, you will have a marginal profit of 0. Okay, next, let's do number 10. Number 10, we're given the cost function, and we're being told that the amount of the input, the items will be bears. And we're asked to find the marginal cost for creating, at that instant, the 100th bear. And use that marginal cost to predict the cost of the 101th bear. Let's find out. First, let's get the marginal cost. Marginal cost function, the constant would be 0. The derivative of 4x is 4, minus 2 times this quantity, which would be 0.002x. Okay, now, at the instant we make bear number 100, our cost will be 4 minus 0.002 times 100, and this will be 4, and 100 times this will bring my decimal up twice, so 1, 2, this will be 0.2, and this will end up being $3.80 per bear. Okay, so to make the 100th bear, it's costing me right at that moment $3.80 to make these bears. Well, let's find the cost of making 100 bears. The cost to make 100 bears is 100 plus 4 times 100, and then 0.001 times 100 squared. And the cost, I'm sorry, it's not marginal, it's just cost. So this will be a 100 plus 400. And when I square this, this will become, let's see, four zeros. And this will move this decimal back 4 times, 1, 2, 3, 4 to a 10. So we'll have 100 plus 400 minus 10. That'll be 500 minus 10, which is 490. Okay, so the cost to make 400 bears would be $490. To make the very next bear, the 101 bear, we know that it's costing us, at that instance, $3.80 to make the next bear. So it'll be $490 plus another $3.80. So $493.80 to make that 101 bear. Okay, now let's look at problem number 20. Number 20 is asking us, it's giving us a formula that says the input in are the number of employees. And as you input the employees, the output will be the profit that you actually get. So as you input employees, you know what kind of profit you'll be making in this function. And the question is, they want to know, when we input 50 employees, what's our profit? Are we gaining profit at that instant? Are we losing profit at that instant when we have 50? So this is a question of instantaneous rate of change when the input in is 50 people, or the input is input of people. So let's find the instantaneous profit. All right, we need to find the derivative of P of N. So the derivative of this will be negative 100. 2 times 25 is 50 into the first power. And 2 times this will be negative 0.01 into the first power. Okay. Now, let's plug in 50. This will give us negative 100 plus 50 times 50 minus 0.01 times 50. We have negative 100. 50 times 50 is 5 times 5 is 25 with 2 zeros. And we have, this will be 5 times 0.1, which will be 0.5. Okay, it's about 50 cents. Yeah. And let's see, this will be 2,400 with this minus a nickel, or sorry, 50 cents. So this will be 24, which is 2,399.50. And it's positive. So, since the output is profit, it's money, and the input in is the employees. So, when we have 50 employees, we'll be basically, at that instant, we'll be able to gain $2,399.50 per employee.